We're going to take a look at this example problem, and we're actually going to make two example problems out of this single question. Here we have three-dimensional vectors, and we're asked to determine whether or not they're linearly independent or linearly dependent. And to do that, we're going to form them into a matrix and determine the rank of that matrix. So first we'll begin by placing these three vectors as row vectors, 1, minus 1, 1, and then 0, 1, 1, then 1, 1, 1. And we'll perform Gaussian elimination on these in order to determine what the rank of this matrix is. So in the first step, we'll transform to this matrix, and the first row is just copied over, 1, minus 1, 1. And it just so happens that the second row starts out with a 0, so all we have to do is copy it over for now. But then we need to get rid of this minus 1 that starts off row 3. So we'll do that by taking the original row 3 minus row 1. So that gives us 0, 0, and then we have 1 minus a negative 1, or 2, and then we take 1 minus 1 and get 0. Okay, we have another step to perform in Gaussian elimination. And we've continued. The first row is just copied over. The second row is copied over. And for the last row, what we'll do is we'll take this row 3 minus 2 of row 2. So we have 0, 0, and then we have 0 minus 2 times 1 minus 2 is what we end up with, and that tells us that we have a rank of 3. And since we have three-dimensional vectors and the rank when we place them as row vectors came out to be 3, then we know that they are linearly independent. So they form a linearly independent set. I mentioned before that we're going to turn this into another example problem, and how we're going to do that is, instead of considering these three vectors as row vectors, I'm now going to place them as column vectors in a matrix and see what the rank of that is. If you read the book, you would have seen that the rank should be the same here, and it didn't matter whether I placed them as row vectors or column vectors. I should get the same result for the rank of the system. So let me begin the problem over again, now placing them as column vectors. So I have 1, minus 1, 1, 0, 1, 1, and the last vector is 1, 1, 1. Now these are placed as column vectors, and when I perform the Gaussian elimination tasks, I copy over the first row, 1, 0, 1. My second row, I need to obliterate that minus 1 and turn it into a 0, and I'll do that by adding the original row 1 and row 2 and letting the result go here. So that will give me 0, 1, 2. And now for the third row, what I'll do is I'll take the original row 3 minus row 1. So that will give me 0, 1, 0. And I'll continue this on. I just copy the first two rows over. And for my third row, what I'll do is I'll take this row 3 and I'll subtract this row 2. So I have 0, 0, minus 2. Again, that gave me a rank equal 3. Same as we had before. It didn't matter whether we placed those vectors as row vectors or column vectors. We got the same result, and they are linearly independent. So we got the same result there no matter how we approach this problem.